Hello and welcome all. Today we students of Computer Engineering of 2020 batch from PDPU are going to present our website we have created for our OS Lab project. We are a team of students helping you to understand different disk scheduling algorithms through this website. So this is our landing page of our website, and as you can see we have different sections created which can be easily accessed using these buttons over here. So let's get started. So some introduction about disk scheduling is a disk is a flat round plate on which data can be encoded and stored. Fixed disk in the form of hard disk are a common component of a computer storage system, and there are basically two types of disks: magnetic disks and optical disks. Let's know something about disk scheduling algorithms. So what is disk scheduling algorithm? Why disk scheduling algorithm is needed? And what is the objective of disk scheduling algorithm? Disk scheduling algorithm is important because there are multiple IO requests which may arrive by the different processes, but only one IO request can be served at a time, and thus the other IO request uh, need to be scheduled. So two or more requests may be far from each other, so can result in greater disk arm movement. Now, hard drives are one of the slowest parts of the computer system and thus need to be accessed in an efficient manner. So the terminologies for the disk scheduling are seek time, rotational latency, transfer time, disk access time, and disk response time. The algorithms that we are going to see today are FCFS, scan, cscan, and look. So let's start with FCFS. FCFS, which stands for first come first serve, and as the name suggests, the request which arrives first gets served first. And FCFS is the easiest disk scheduling algorithm among all the algorithms. And the starvation does not occur in FCFS as it addresses each request. In this page, there are three buttons. One is home button, which leads to our home page of our website. Then there is one algorithms button, which is a drop down button through which the user can go to other algorithm easily. And the other is algorithms graph button, which we will see now. Here we need to enter the values in the queue and in the head. We need to make sure that values are positive and total number of entries are 10 in the queue, so graph created can be viewed easily. So let's enter some values in the queue. So when we click calculate, the algorithm gets executed and the graph is displayed, and we also get the total seek time in which is 238 in this case. User can also download the graph from this button or else zoom in or zoom out using the tools we have provided. And user can also explore the other tools which we have provided here. So this was all about FCFS. Now let's move to the next algorithm, which is scan. Scan algorithm. As the name suggests, algorithm scans all the cylinders of the disk back and forth. So the head starts from one end of the disk and move towards the other end, servicing all the requests in between. And after reaching the other end, head reverses its direction and move towards the starting end, servicing all the requests in between. And the scan is also called as elevator algorithm as its working resembles the working of an elevator. So now let's see the algorithm's graph. So we enter the values of the queue and enter the value of head. In scan algorithm, we need to select the direction in which the algorithm should work. So we select the right direction and let's hit calculate. So we get the graph and we can see the total seek time is 336. When we select the direction left and hit calculate, the graph changes and we can see that total seek time has changed to 140. If a user enter a negative value, then there is a prompt which is provided, which tells the user that the range should be between 1 to 199. So this was all about scan. Now let's see C-scan algorithm. C-scan algorithm, which means circular scan algorithm. It is an improved version of scan algorithm. In this algorithm, the head starts from one end of the disk and move towards the other end, servicing all the requests in between. After reaching the other end, the head reverses its direction and then it returns to the starting end without servicing any request in between, and the same process repeats. The difference between C-scan and scan is in this algorithm, in C-scan, there are more seek movements as compared to scan, and it causes the head to move till the end of the disk even if there are no requests to be serviced. But in this, it provides uniform waiting time, and it also provides better response time than scan algorithm. Now let's see the algorithm's graph. As done before, here also we enter the values of the queue and enter the head and make sure that all the values are positive. Here also we select the direction. We select right and hit calculate and we can see the graph and total seek time is 393. When we select left, we can see the graph changes and total seek time is 380. So this is all about cscan disk scheduling algorithm. So now let's see look algorithm. Look algorithm is an improved version of scan algorithm. In this, the head starts from the first request at one end of the disk and move towards the last request at the other end, servicing all the requests in between. After reaching the last request at the other end, head reverses its direction and then returns to the first request at the starting end, servicing all the requests in between, and the same process repeats. The main difference between scan and look algorithm is scan algorithm scan all the cylinders of the disk starting from one end to the other end, even if there are no requests at the ends. And look algorithm scans all the cylinders of the disk starting from the first request at one end to the last request at the other end. Now let's see the algorithm's graph. Here we again enter the values as entered before and enter the head, and keep in mind that we enter positive values and in the range of 1 to 199. Here we select the direction which is right and hit calculate, and we can see the graph and total seek time is 118. And when we select the direction left and hit calculate, we can see the graph changes and total seek time is 116. And this was all about look disk scheduling algorithm. So this was all about the algorithms from our side, and we hope we were able to show you how the algorithm work and you were able to understand them. So we are team 6 of G5 Division 3. The front-end work was done by Mihan Jhaveri, Krushabh Patel and Ketankumar Rathod, and the back-end work was done by Dhruv Rajvansh, Arbaz kaladiya and Nishk Patel. We hope that you liked our website and thank you for watching this video.